All right, let's take on a more complex task. This will be the most significant, the most complex piece of code that we've written together. I've described the tasks that I wish to carry out in the comments on the program that otherwise I have not begun. It says this: for a given positive integer n, that'll of course be the input, return the first positive integer that has at least n distinct prime divisors. Let's talk about what that means precisely before we actually start to write code. First of all, prime divisors. Well, hopefully you do recall what a prime is. The primes begin at 2, go to 3, and then 5, and then 7, and so on. And what makes a number prime? What's our definition of prime? Well, the usual modern definition of prime is that a number is prime when it has precisely two distinct divisors. So for instance, then 2 is certainly prime because its distinct divisors are 1 and 2 and no others. So it has just 2. 3 also has just 2 distinct divisors, that is 1 and 3. However, when you consider 4, of course it's divisible by 1 and itself, that is by 1 and 4. However, it is also divisible by 2, so it has more than one distinct divisor, so it is not prime. Do note as well that 1 does not count as prime on this modern definition of primes because 1 has only one divisor, that is itself 1, but primes need two distinct divisors. Okay, so that's what we mean by prime. And now let's talk about what we mean by the phrase at least n distinct prime divisors. Consider, for instance, the number 2. It has one distinct prime divisor. It's divisible by 2. How about 3? Its only prime divisor is 3. Yes, it's also divisible by 1, but I said before that 1 does not count as prime. How about 4? Well, 4 is divisible by the prime 2 and by no others. How about 5? Well, it's divisible by 5. How about 6? Ooh, it's a bit of a change here. It's now divisible by both 2 and 3 and by no other primes. So it has two distinct prime divisors. So if, for instance, this function that we're about to write, if we were to send it the value 2, that means we want the first number with at least two distinct prime divisors. It should return 6. Okay, that should return 6. Well, let's begin to talk about how it is that we would actually write some code here. Now, this is a more complex kind of task, and I haven't chunked this up into functions for you yet. So let's actually think about what functions we would actually write. Now, my recommendation here is this, is that we write one function per task which we wish to carry out. And if we discover in the construction of some function that it's actually multitask, then we should break that into multiple functions. Okay, so let's think about what our tasks are, what we need to be able to do. Well, we need to be able to say whether some number is prime. Okay, that's not, of course, the entire problem here, but that's part of the problem. We need to know what numbers are prime, so let us write a function to do that. And then we also need to be able to count the number of distinct prime divisors of a given number. So we'll also write a function to do that. And then third, we'll write a function to find the first positive integer with at least n distinct prime divisors, which is the final task, of course, that we wish to carry out. And notice that that final task, the real task here, will depend upon the previous two. That is, we're about to write some functions that we'll call other functions, which is often a very good idea about how to write your code. Okay, so let me write just skeleton functions for these. So how about an isPrime function? So isPrime will take some positive integer n, and it will return true when that number is prime, false when it's not. So I'll write that just in just a moment. We'll also write a function called the number of prime divisors for some input number n, and it will return, I'll comment this to make it sure it's clear, return the number of distinct prime divisors of n. Oh, and I should make a comment here about distinct. Maybe that wasn't clear before. Consider the number 8, for instance. How many distinct prime divisors does it have? Well, 8 is 2 to the third power, so it's 2 times 2 times 2. So in a way, it has the divisor of 2 3 times over, but that only counts for us as one distinct prime divisor because it is 2, again, 3 times over. Okay, so we'll also write a function then to return the number of distinct prime divisors of n. And then finally, we'll have this function, which will, what should we call this? First, how about this? First with n. Okay, and it'll take some input number, which perhaps we shouldn't call n, because we've already given a name for n in the name of the function. So let's see. So return the first positive integer with at least n. Oh, no, actually, I don't know why I decided to call that m. We should definitely call that n. With at least n distinct prime divisors. Comments on code, especially functions, are a very good idea, especially if they're a little bit harder to understand. It really does help a reader of your code if you tell them what the function is supposed to do. You don't have to go into great detail, but just to simply tell them, you know, the kind of value that it gets, the kind of value that it returns, what it does for the user is extremely helpful. Okay, so actually, let's start to write this code then. So back up to the isPrime function. Okay, so remember the definition. A number is prime when it has only two distinct prime divisors. That means that a number isn't prime when it has three or more distinct divisors. Okay, now, of course, every number is divisible by 1 and itself, so that means that the non-primes will be divisible by something between 1 and themselves. So that suggests a certain technique here. Let us iterate from 2 to the number -1. If we find any divisors in that range, then we know that the number cannot be prime. But if we find no divisors in that range, the number will be prime. Oh, yeah, and just a little reminder about divisibility. How do we check for divisibility? How do we know, for instance, or how does Python know that, well, I don't know, 9 is divisible by 3? Well, we ask whether the remainder is 0. Okay, that's what divisibility means. It means the remainder is 0. So look, we just asked Python to extract the remainder when 9 is divided by 3. That's the 9% symbol 3. And then we ask whether that remainder is equal to 0. And the answer will be true. So that's Python's way to tell us that 9 is divisible by 3. So is 9 divisible by 4? Absolutely not, because that leaves a remainder of 1, and 1 is not equal to 0, so that's false. So that's how you test for divisibility. Ask whether the remainder after division is 0. All right, so apparently we need to do this. Okay, so we're going to go from, I'll use the variable f for potential factor for f in range. And again, what we want to do is we want to go from 2 to the number -1. Now you remember the Price is Right rule for the stop value on ranges. We don't actually get to that n. It will take us to n-1, which is precisely what we want. Okay, so what we wish to do is we wish to check whether any of those numbers between 2 and the number -1 divides n. Okay, so let's do a test. We do that with if, right? So if, okay, so let us ask whether n is divisible by that f. Okay, so I just did that. I asked whether n is divisible by that f, just like we did in the console a moment ago. So if that's the case, oh, that means that we found a divisor in the range from 2 to n-1, which means that this number cannot be prime. Okay, so in a case like this, we just go ahead and return false. Okay, there's no reason to continue to check. We found a divisor between 2 and the number -1, which means that it cannot be prime. Okay. Now let's think about what happens if we're able to get all the way through this for loop and not find any divisors in the range 2 to n-1. Well, that means, of course, that the number has to be prime. So we can simply return true. And notice the level of indentation on line number 8. It is the same as line number 5, which is the first line of the body of the function. And that, of course, is the for statement. So line number 8 executes only after the for loop is complete. That means that we will have found no divisors between 2 and n-1, which means that the number has to be prime. Okay, so of course, once we write a function, we test that function. So let us test the function is prime. And we'll just do the usual sequence here. So 2 and 3 should be true and true. 4 should be false. Let's think about what happened when we sent 4. Okay, so we had for f in range 2, 4, which is the list 2, 3. So on line number 6, we asked first whether that 4 was divisible by 2, and the answer was yes. So we returned false in that case. And of course, once we hit the return statement in a function, the function is done. So we returned false. How about a few more? So how about 5? That should be true. How about 6? That should be false. Okay, so how about, I don't know, a bit bigger of a number, 21 should be false because that's divisible by 3. as an addition to 1 and 21. So how about 23 should be true? Okay, so I have great confidence in this function that it does correctly return the answer to the question, is this number prime? Okay, so let's return the number of prime divisors of a particular number. Okay, so a particular input number. Well, what we need to do is this, is we need to go from 2 up to the number, okay? 2 up to the number and check whether any of those divide the number and are prime, okay? We need to have both of those properties. It needs to divide the number and be prime for us to increase our count of the number of prime divisors. So we need a count variable. Okay, so we'll initialize that to 0. Oh, yeah, and as for why it is that we need to go all the way up to n in this case, because of course it's entirely possible that the number n is itself prime, like for instance 5. How many distinct prime divisors does 5 have? Well, 1, because it itself is prime and it is divisible by itself. So here we go. We better do a for loop for potential factor in range. Now we do wish to start at 2 because we know that 1 is not prime. So we will start at 2 and we will go up to all the way up to n in this case. Okay, so the stop value needs to be specified as n plus 1. And then we need to do a test. We need to do a complex test, right? So if n is divisible by that potential factor f, okay, so we just ask whether it's divisible and is prime n. We need for both of these to be, is prime f. We need for both of these to be true, okay? And notice that that second part of this complex expression, the part after the and, the is prime f, that's a function call, okay? And its value is the value returned by the function. But that function returns either true or false. So that is a Boolean, which is precisely what and demands. So we're good with that. So if that f does divide the n and it's prime, then the count should increase by 1. And then once the for loop is complete, so there we are at the same level of indentation as the for, we return the value of count. Okay, so we not only write functions, but we also test them. So let's see, num prime divisors of, and we'll start with 2. Actually, let's just see what it does with 1. Let's see if it handles that edge case appropriately. It does. So how about 2? The answer here should be 1 because 2's only prime divisor is itself. Yep, that's correct. So how about 3? Right. So how about 4? That should also be 1 because its only prime divisor is 2. 5, its only prime divisor is itself. Now 6, oh, it has 2 prime divisors, which are 2 and 3. That's exactly right. Really interesting. I think that this function is correct. Okay, so now let us find the final function, which is the real purpose of this exercise. For some input value n, let us find the first positive integer, the smallest that is, that has at least n distinct prime divisors. Okay, so here's what we need to do. Okay, I think I'm going to do this as a while true loop. Okay, I think we talked about this before in a previous video, but I think I'll do it as a while true loop. And then we'll break out of it when we need to. Okay. Now, as for why this needs to be a while loop and not a for loop, well, at the start, we just have absolutely no idea how many times we'll have to iterate, right? Could you tell me, like, just off the top of your head, if the input number was 4, that is, we wish the first number with 4 distinct prime divisors, how many times we'd have to iterate through how many numbers we'd have to iterate to hit that one with at least 4 distinct prime divisors? The answer is no. You don't know what that is off the top of your head, right? So you cannot set this up as a for type iteration, that is a definite iteration, because you do not know at the start how many times you will have to iterate. Instead, you'll have to do tests, okay? Now, we could put the test after the while, but actually I think it'll make more sense in this case to simply write this as a while true and then do a test inside of the while loop. And if the test uh, gets the answer we want, that is, we finally get one with indistinct prime divisors, we'll just simply break out. Remember, that was our final keyword of the chapter, break. Break will end the loop. Okay, so let's see. How about some prime divisors? I'll simply call that P. Let's see. So that will be, oh, now let's think about this task, okay? Let's think about this task. We have to test a certain number, okay? To find out its number of distinct prime divisors. And if it doesn't have enough, we have to go to the next one. Okay, so let us call that number 2. Okay, so we'll start with 2. We know that that's the first number with one distinct prime divisor, so we'll start with 2. And then we'll ask how many prime divisors it has. And if it's enough, if it's at least equal to n, we'll break out and be done. If it's not, we'll have to increase m. Okay, that's really how we have to do this. There is a kind of loop variable here, and it's m, but we have to handle its value ourselves. Okay, so how about this? I will let p be the number of prime divisors. I have a function for that. Prime divisors of that m. Okay, so how about this? If p is greater than or equal to n, that's the input value, that's the number of prime divisors that we wish to get, then we'll break out of this particular while loop. Okay, that's what break will do. It'll break out of the loop, it'll stop the loop. Otherwise, actually here we don't need the else, but it might be logically clear. The reason we don't need the else is because if we break out, the while loop will be done, and then we'll automatically do line number 26 whether we put the else or not. But I'll go ahead and put the else. Okay, so that is this else is tied to the if. Okay, so that means that we don't have at least n prime divisors. So what we have to do is we have to increase the value of m by 1. So the next time through the for loop, we'll get the number of prime divisors of that increased value of m. Okay, so line number 28 at the same level of indentation as the while is where we will be if we have broken out. So in this case, we will simply return the value of m. So let's see. First with n, hopefully that's 2. Yes, what is the first number with at least one distinct prime divisors? Indeed, that is 2. So how about 2? Oh, that's 6. We knew that to be the case. How about 3? Interesting. So what are the distinct prime divisors of 30? Well, 2. 2 divides 30. 3. 3 divides 30. 5. 5 divides 30. But that's it. That's really interesting. I wonder what 4 was. Ooh, that's actually pretty big. I didn't know that off the top of my head, did you? So that's why we didn't use a for loop. So how about 5? Dang, gets pretty big pretty quickly, right? Ooh, I don't even know how long this one will take to terminate. The jump from 210 to 2310, that was approximately 10 times larger. I have no idea how many times larger this will be. Huh. Well, you might let this run on your own just to see how long it will take. It will apparently take a little while. All right, so that's some code. Here are examples of how it is that you can chunk a task up into multiple functions. Here are examples of for loops and of while loops as well. Here's an example of how it is we check for divisibility. And here's an example as well of how we use the if, elif, else type structure to perform tests.